At the Otokumpu Kemi mine, all mining operations are underground. Tunnels are supported with rock bolts and, where required, with meshing and shotcreting to ensure that all the mining processes are safe. Drift tunnels are cut and blast holes for stopes are drilled and blasted. Ore is loaded from the stopes by trucks and fed underground to the crusher at the base of the mine. The crushed ore is hoisted to the surface via a 550-meter deep shaft. All completed stopes are then backfilled with barren rock and mining continues upwards. At the surface, chromite ore is crushed again and concentrated into upgraded lumpy ore and fine concentrate. In the first concentrating stage, upgraded lumpy ore is produced by using heavy medium drum separators. In this process, pieces of ore with the highest specific weight are separated from the rest of the ore feed. The next stage is the fine concentrate plant, where the crushed ore is ground into smaller pieces in the rod mill, and then the chromite mineral is separated by gravity separation. Both upgraded lumpy ore and fine concentrate are transported to the Tornio ferrochrome works. Fine concentrate arrives from the Kemi mine and is mixed with bentonite and coke dust and fed into the pelletizing drum. The pellets are then fed into the sintering furnace. After sintering, the chromite pellets are ready for use. A dosing system charges the smelter with chromite pellets, quartzite, coke, and lumpy concentrate. After smelting in the furnace, the ferrochrome smelt is tapped into a ladle and the slag byproduct removed. CO gas produced by the smelting process is recycled for use in the ferrochrome works and the rolling mills. The molten ferrochrome is then transferred by rail to the adjacent steel melting shop. Molten ferrochrome that is not required by the melting shop is poured into casting ditches, where it is cooled and crushed. The solid ferrochrome is then either stored for later use or sold on the international market. Recycled steel, which can account for up to 90% of the raw material used in Otokumpu's stainless steel production process, is dried before melting. Molten ferrochrome, which arrives directly from the ferrochrome works, is poured into a ferrochrome converter, where silicon and some of the carbon is removed from the melt. By using molten ferrochrome in the ferrochrome converter, Otokumpu achieves significant energy savings and an increase in production capacity. In the steel melting shop, an electric arc furnace is charged with recycled steel and other raw materials, such as nickel, molybdenum, ferrochrome, and coke. Once the charge has melted and the slag is removed, the melt is mixed with ferrochrome melt and transferred by ladle to the AOD converter. In the AOD converter, carbon and sulfur are removed, and the alloying is made to create the specified stainless steel grade. The melt is poured into a ladle and transferred to the ladle treatment area, where final adjustments are made before casting. The melt is then transferred to a continuous casting machine, where the steel is cooled and cut into slabs of stainless steel approximately 14 meters long and weighing 20 to 26 tons. Each slab is marked with its own unique customer order code. These slabs are then transferred to the hot rolling mill. The slabs are first transferred to a walking beam furnace, in which the temperatures of the steel is raised to more than 1200 degrees Celsius. The slab is then rolled backwards and forwards a number of times through a roughing mill, reducing its thickness and increasing its length and transforming it into a transfer bar. Passing the transfer bar through the Steckel and tandem mill further reduces its thickness. It is then coiled and moved to a cooling pool. After cooling, most coils continue to cold rolling plant or are sold as black coils. Some of the coils continue to the bell furnaces to homogenize the microstructure of the steel, after which the coils continue to cold rolling. Coils produced by the hot rolling mill are covered in black scale. In the cold rolling plant, coils are unrolled and passed along an annealing and pickling line, which recovers the mechanical properties of the steel, removes the scale, and changes the steel surface from dull black to silver grey. The acids used in the pickling process are recycled through acid recovery. The coil is then rolled to its desired thickness, which can involve a reduction of over 80%. In order to recover mechanical properties, the cold rolled steel is annealed and pickled again. After this, the coil undergoes polishing treatment to improve its surface finish in the skin pass mill and coil polishing line. The stainless steel products are now slightly shiny and have a good flatness. The stainless steel coil then reaches either the slitting or cut-to-length line, where the steel is finished to the required dimensions, either as coils or as individual sheets. After the slitting and cut-to-length lines, the products are moved by automatic guided vehicle to the automatic packing area. A continuous rolling, annealing and pickling line, known as a wrap line, occupies all 3 floors of the plant. Steel strip passes through the wrap line twice. On the first pass, black hot rolled coil undergoes annealing and pickling and emerges as white hot band. During the second pass, the material is cold rolled and its thickness is further reduced. The final product is stainless steel cold rolled coil. Otokumpu stainless steels come in a variety of product formats, including slabs, hot and cold rolled coil, precision strip, sheet, plate, quarter plate, and stainless steel long products, including billets, bar, tube, and wire. All of our products are made from between 70 to 90% recycled materials and are fully recyclable at the end of their life cycle. Otokumpu's production facilities are located in Finland, Germany, Mexico, Sweden, the UK and USA, with a global sales and service centre network always close to our customers.